Welcome to Easy Elim Learning Simplified. My name is Ruth, and the topic for today is structure and bonding. And today we are going to be looking at covalent bonds. So previously we looked at ionic bonding. For today, we'll look at the introduction bit of what covalent bonds are, and then we are going to make some few examples of covalent bonds and end the session. So covalent bonds is a bond that is formed when two atoms of the same or different elements share electrons to be stable. So we can say that this is a bond formed when two or more atoms contribute equally to the shared pair of electrons. I want you to note the shared pair of electrons. There's always two electrons that are being shared. They're either shared equally or later on you notice it can also be shared by only one atom. But in this case, it's just two atoms or more that are sharing those electrons. There are two or more because we'll be talking about two, they'll be working with in twos. We can have different twos or two different pairs. You can have more than one pair, but you'll be working with just a pair of electrons. So we are going to present this in dot and cross structures using the Lewis dot and cross and this other normal dot and cross structure. So covalent bonds are usually lead to the formation of a molecule. These molecules can be similar or different. You're going to see that, and they're usually formed basically from nonmetals. So a molecule is a group of atoms of the same or different elements held together by strong covalent bonds. So let's start with chlorine molecule. When I talk about chlorine molecule, it's going to be written as Cl2. So we are going to present this with the circular dot and cross, and then also I'll show you another method to show this. So first of all, we identify the number of electrons in chlorine. Chlorine is number 17. So the configuration is 2.8.7. The other chlorine atom, because we have two of them, is also 2.8.7. So when we are drawing the dot and cross structures of covalent bond, first of all, we do not draw these two shells inside. We only draw one shell, the outermost shell. We do not draw the inner shells to make our work easier so that we can see how the electrons are moving about. So when we are drawing those circular circles, we put them like they're being shared. They need to crisscross. For example, for chlorine, we are going to draw one chlorine atom. They need to be on the same size. And then you can see they are crisscrossing each other. We are going to be having crisscrosses, circles throughout this covalent bonding and coordinate bonding. So next you draw the symbols in the separate atoms. And then now we need to figure out how many electrons are being bonded or shared. So when you look at the first chlorine atom, it requires one electron to be completely full. The second one requires one electron to be full. So there's a principle that I usually use to help me to understand and to be able to make it easier for me to write these dots and cross structures. So the principle is the amount of electrons that you need to be able to be completely stable is equal to the amount of electrons that you need to contribute. For example, the first chlorine atom requires one electron to be full. So that chlorine should also be willing to share its one electron. The second atom also requires one electron. So it should also be willing to share that one electron. So when you look at the first chlorine, it shares one electron. And when we are using a pair of electrons, we show with a dot and cross. So the first chlorine will share one electron with an X, and then the second chlorine also requires one electron, so it should be willing to share its one electron. It's a give or take situation. So when the first chlorine has shared its one electron, we are left with 6 electrons in the outermost shell, and the second chlorine also we are left with 6 electrons. This is what we show. The remainder is what we show in the outermost shell. So the first chlorine we use X's and there are 6 of them remaining. And the second chlorine we use dots and there are also 6 of them remaining after sharing. So if you were to count the total number of electrons in each atom, you can see in the first chlorine, the one that I'm circling, if you count the number of electrons in the first chlorine, you notice there are 8. You count together with the ones that are being shared. So it becomes 1, 2, 3, 4, 5, 6, 7, 8. If you count the number of electrons in the second chlorine as well as a whole together with the shared electrons, it will be 1, 2, 3, 4, 5, 6, 7, 8. So you notice we have 8 electrons this side, 8 electrons this side. So everything is balanced. We didn't show the innermost electrons, and we only worked with the amount of electrons that are being shared. Let's do another example of elements or molecules made of the same atom. Oxygen molecule. So oxygen molecule is the atomic, it's O2. So the first oxygen has 8 electrons, so it's 2.6. Second oxygen has also 8 electrons, the atomic number, so it's 2.6. I like separating so that I can see how the sharing is happening. So we draw two circles because we are working with two atoms and they are of similar type, so they need to be in the same size. And then we write the symbols at the center. And then next we need to figure out how many electrons are being shared. So the first oxygen requires 2 electrons to completely be full. So it should be willing to share those 2 electrons. So when you look at the first oxygen, it shares 2 electrons. So if it shares 2 electrons, it's left with 4 electrons. So we put the remainder of 4 electrons. The second electron, oxygen as well, requires 2 electrons to be completely full. So it also needs to share 2 electrons since it needs them. So it shares 2 electrons. You see how we use the dots? And after it shares 2 electrons in the outermost energy level, it is left with 4 electrons. So those are the 4 electrons that we are going to put. Notice how we are putting them side by side in the circle where they are sharing. Do not write X and dot and dot. Or this one is allowed because they are side by side, but this is not allowed. Dot and X and X. So dot and X and X. If you do it this way, they do not show like how they are being shared. We said it's a pair. We need to always see that pair of electrons coming from two different atoms unless it is a special type of a covalent bond, which is later on. So if you count the number of electrons in each oxygen atom, you notice they are equal. So let's count in this first oxygen. So it is 1, 2, 3, 4, 5, 6, 7, 8. Let's count in this second. 1, 2, 3, 4, 5, 6, 7, 8. So it is correct. Let's look at a molecule formed by different atoms or elements. So hydrogen chloride, we have hydrogen and chlorine. Hydrogen is atomic number 1, chlorine is atomic number 17. So the configuration of hydrogen is 1, of chlorine is 2.8.7. Second, we draw, because there are two circles, they are of different sizes, we make them, they are of different sizes. So we put hydrogen at the center, the other ones needs to be a bit bigger because it represents chlorine. So we start one atom at a time. So the first hydrogen atom has 1 electron in the outermost shell. So it requires 1 electron to be full. So it needs to share that 1 electron. So you put an X. So if it shares 1 electron and it had 1 electron, is remaining with none. This is in the outermost shell. If you look at the outermost shell of chlorine, it has 7 electrons. It needs 1 electron to be completely full, so it needs to share that 1 electron. We use a dot to show the difference. The moment it shares one electron, it is left by 6 electrons. So we put those remaining 6 electrons and then we count. Always count afterwards to ensure that they are both balanced. So our chlorine atom has 1, 2, 3, 4, 5, 6, 7, 8, and then our hydrogen has 2. So both hydrogen and chlorine is balanced. Let's look at another example, water. So water is H2O. So we have 2 hydrogens, is as I said, I like separating, and 1 oxygen. The first hydrogen atomic number 1, configuration 1. Second hydrogen atomic number 1, configuration 1. Third hydrogen atomic number 1, configuration 1. Oxygen atomic number 8, configuration 2.6. So when we draw there are two, remember there are two similar and one different. So the oxygen is going to be at the center, and then we need hydrogens that are smaller, two surrounding the oxygen. That's how it looks like. So we put the symbols just like before, and also the oxygen. So the first hydrogen requires 1 electron, so it needs to share that 1 electron. So we use the same type of dot of cross with the hydrogens. The second, I've left, this one was not supposed to be there. The second hydrogen also gains 1 electron, so it should also lose 1 electron, so you show that also. So when they do so, remember they both had 1 electron in the outermost shell, so they are left with none afterwards. Oxygen in the outermost shell, it has 6 electrons. For it to be completely full, it needs 2 electrons. So it needs to share those 2 electrons. So it will share them equally because it is surrounded by 2 hydrogen. So it will share 1 electron in the first hydrogen and the second electron in the second hydrogen. What it does so, it remains with 4 electrons in the outermost shell. So we show those 4 electrons. So that is how we write water molecule and draw it. So I told you that we are going to use a different method also to show this compound. So let's go back to the first element, the first molecule we drew. So if you look at the first molecule, we can represent this using lines. So the first thing we draw the first atom. And then every time you draw one line, it presents a pair of electrons. If there are 2 lines, it means we have 2 pairs of electrons. Every one line represents 1 pair. So you can see from chlorine to the other chlorine, there are 2 electrons or a pair. So that is going to be represented by one line. So the next chlorine. So you after that you put the remaining electrons outside, you show them, and also this one you show them. So let's repeat the same thing with our next example. So it becomes, so we have an oxygen and oxygen, but we have now 2 pairs or 4 electrons. So that will be 2 lines. Each line, remember, represents a pair of electrons or 2 electrons. And then around the oxygen, we put the remaining electrons that have been shown. So this one had 4 extra ones, and then the other one also had the 4 extra ones. And you can see we are still maintaining the dot and cross. You need to differentiate the 2 atoms. So next we go to hydrogen chloride. Remember we put hydrogen and chlorine or chloride ion, and you see what they are sharing are 2 electrons, so it's going to be one line. And then we put the remainder. Hydrogen did not have any remainders, but chlorine had 6 electrons remaining. So you show that. And finally, this is the water we just discussed. So we have hydrogen, oxygen, and hydrogen. So these two, a pair of electrons, sorry, is going to represent one line. This a pair of electron is going to represent another line. And then we put the remaining electrons outside the specific atoms. So this is now another way to represent the covalent bond. So I hope you have been able to see how a covalent bond works. Go and check more examples and try to practice on them. See you in the next lesson as we discuss on coordinate boards.